So, given the incredible variability in calf elk survival that we observed in 2002 relative to subsequent years, the next obvious question is, how common is this variability in calf survival within populations of elk across time and from one elk herd to the next across space? So in this second and final chapter of your case study, I'm going to walk you through this Journal of Wildlife Management publication that myself and some amazing co-authors published back in 2007. So those are Dr. Matt Kaufman. He's at the University of Wyoming. He's the leader, the research leader for the Wyoming Cooperative Wildlife Research Unit, and my mentor and advisor, Dr. Dan Pletcher. At that time, he was the director of the wildlife biology program at the University of Montana. This publication has been well received. I actually looked it up before I started, and it's now been cited 207 times. But it really empirically demonstrates just how common variability is in calf elk survival. What we saw in the Blackfoot Valley is not unusual. Let me show you what I mean. So what I did is a meta-analysis. So I pulled data from published sources and technical reports, anything that I could find that estimated elk survival rates and fecundity rates. So I was able to acquire data from 40 different sources. And I created mean vital rates, a mean elk population model of these 40 data sets on elk. So if we just look at calf elk survival, there were 10 different studies that I used, 43 different survival estimates from 13 locations, and those were derived from over 1,300 radio-marked elk. So that's a large sample size. And the grand mean across all of those studies and all of those locations was about 35% is the average annual calf elk survival rate. But look here. Look at this variability. So calf survival ranged from just 6%. So those data are from Yellowstone National Park in 1988, following some horrific fires, all the way up to 72% reported on the National Elk Refuge. So compare that to, this is adult female survival. This is all the age classes compressed together. So average female elk, the survival rate that are not calves, yearling and older, is about 87%. But look at this. It only ranges from about 64% to 99%. So if we look at the process variance, that is to say, the variability that is true to these rates, that's not variability that's generated by sampling. So we've removed the sampling variance, and I'm not going to get into the statistics on how we did that. But what I want you to note is variance in calf elk survival is an order of magnitude greater than with adult female survival. Okay, so it's highly variable. The second most variable rate is, just like we would predict, yearling pregnancy rate. Okay, but you recall from our last lecture. So elk are these long-lived species. So there's trade-offs between investing in their survival at the moment and ensuring that they have future reproductive opportunities versus investing in reproduction now. And so elk are going to buffer their chances of survival by foregoing their reproductive effort at this moment. So as we would predict, adult elk survival is high, it's relatively fixed, and it doesn't vary very much. But calf survival is all over the place. It's highly variable, as is yearling pregnancy rate. It ranged from no yearlings becoming pregnant to 50% of the yearlings. So again, we have quite a bit of variance here in yearling pregnancy rate. Prime-aged pregnancy rate doesn't vary very much, right? And then if we look across the age classes, there's not a lot of variability in the survival of any of these age classes. So it's the variability, the true variability in elk population dynamics is driven by calf elk survival and yearling pregnancy rate. So really quickly, elasticity is a type of sensitivity analysis. And what elasticity is going to do is, so you've got this matrix population model that we built using all those mean vital rates on the last slide. So what elasticity does is it holds all of the vital rates in the matrix population model steady, and it just increases one vital rate and then looks at the relative contribution of that rate while all other rates are held constant. So what is elasticity? Elasticity is a measure of a vital rate's impact, its relative contribution on lambda, on the population growth rate. So the higher the elasticity associated with the vital rate, the greater its impact on lambda. So if it has high elasticity, just a little bit of change in the vital rate value is going to cause large change in the population growth rate. Again, population ecologists are going to use elasticities, this sensitivity metric, to determine how small proportional changes in each of these vital rates, survival of calves, survival of prime-aged individuals, fecundity of yearlings, how small changes in those vital rates ultimately impact population growth rate. In elk, like in other long-lived large vertebrates, the survival of prime-aged females has the greatest elasticity. So survival of prime-aged cows is going to have the greatest impact on lambda. So for example, if you have a 10% decrease in the survival of adult cow elk, that's going to translate into a much greater decrease in population growth rate than a 10% decrease in the survival of calves. This is why, historically, wildlife managers have been so successful meeting ungulate population targets through the management of cow permits, cow harvest permits. This is the wrench, right, to control the size of the population. You do it with your cow tags. So which elk vital rate below has the greatest proportional impact on lambda, the finite population growth rate? In other words, changing which vital rate below will cause the greatest change in the population growth of this elk herd. Okay, and hopefully you see it. It's survival of prime-aged females. All right, so survival of prime-aged females has the greatest elasticity, the greatest effect on lambda with a unit per unit change. But that said, in the real world, adult female survival simply doesn't vary that much. So we've come back to this grand table, and I'm highlighting total process variance, which I've explained to you. Which two elk vital rates show the greatest process variance across time and space? And hopefully you can see that now. So prime-aged adult female survival has the greatest elasticity, but calf survival has the greatest inherent variability. So which should managers be focused on? So to connect elasticity with our empirically derived estimates of variability, we used a simulation technique called life stage simulation analysis. So this was developed by Wisdom and Scott Mills. And Scott was really helpful. Again, he was my instructor for population ecology, really helped me with this analysis. So it's a simulation-based context within which you're going to randomly pull vital rates and build elk populations from the distribution of vital rates that we define based on our means and our inherent process variance. I know that's a lot to think about. You're not going to be tested over the nuts and bolts of this, but this might make it a little more clear. So I used this simulation approach and I generated 1,000 hypothetical elk populations, drawing vital rates from distributions of vital rates, and I defined the distribution based on the mean and the process variance that we observed in the real world. Okay, so these were realistic hypothetical elk populations. And then we regressed the population growth rate in each one of these simulated populations on the calf survival rate on the x-axis on the left, and then prime-aged cow survival rate on the right. And look at this. 75% of the variation that we saw in these simulated elk populations was attributable to calf elk survival, in comparison to only 16% of the variation attributable to prime-aged cow survival. So what does that mean? So yes, prime-aged cow survival has the greatest elasticity, but because it's just not very variable, because it's relatively fixed, it's not really contributing that much to the variability that we see from year to year in elk abundance. Most of the year-to-year variability that wildlife managers document in elk abundance is attributable to calf survival from the previous year. Although calf survival has lower elasticity, it has so much inherent variability that it is actually explaining most of the variability that managers see in elk population growth. So which elk vital rate had the greatest impact on variation in elk population growth rates, both within populations over time and across populations over space? In addition to meeting population targets with cow-elk permits, which have high elasticity, what else do wildlife managers need to measure to understand variation in elk population abundance from year to year? I know that's a mouthful. What do wildlife managers need to have a handle on? Calf elk recruitment. Okay, because that's a reflection of survival, and it's calf elk survival that's driving most of the variance in population size from one year to the next. So in conclusion, this is a great example of data-driven wildlife management. So making decisions for wildlife based on empirically derived estimates as opposed to public opinion. So calf elk survival is the most important metric in detecting changes in population growth rates. Bear predation on neonates can be important in some years. It was certainly important in Yellowstone. The work that we did was replicated in Yellowstone National Park by Dave Meach and Shannon Michelle Barber, and the grizzly bear predation was very, very strong. But on private lands, bear predation, at least what we saw, can be important, but it's going to interact strongly with spring weather conditions. So when spring conditions are poor, bears may become more carnivorous, more reliant on catching and killing calf elk. And then in the Blackfoot Valley, suppressed calf recruitment was primarily driven by increasing elk densities that occurred on private lands, on these private ranches, these beef ranches that were restricting public harvest. So again, our recommendation was to continue to work with private landowners to create conservation easements, agreements with the landowners that's going to allow the public onto these private lands to harvest elk in these areas where they're found. So this is what made all of the work possible. Funding from the Rocky Mountain Elk Foundation, Boone and Crockett, and Safari Club, and then of course amazing support from Montana Fish, Wildlife, and Parks, particularly the wildlife manager Mike Thompson, incredibly amazing mentor. I had an awesome committee, Dan Pletcher, who I've mentioned, Carrie Forsman, and the late great Dr. Jack Ward Thomas. So with that, I hope you enjoyed this. I hope it gave you a window into what it's like doing research for a state fish and game agency and solving, or at least working to solve, management issues. So if you want to talk about this further, I always am looking for an opportunity to geek out on elk or other wildlife management issues. So reach out to me. I'd love to talk to you. Okay, thank you so much for your time. Cheers.